What's up guys, so today in this video we will be seeing the efficiency of my ZVS and flyback circuit right here, and I'll be also explaining of how to get your ZVS and flyback circuit as efficient as mine, because my ZVS and flyback circuit can sustain an arc for 5 minutes without getting the MOSFETs to junction temperature. So let's not talk and waste time and get to the actual stuff. So let's get started. So this is the ZBS and the flyback circuit that I was talking about. So as you can see here, in this ZBS, I have used a choke. I had a FZ44N MOSFETs, some resistors, and some Zener diodes and fast diodes, and a separate a primary and a high voltage flyback transformer. I used the it's the BSC 23NO N0171 flyback transformer. And the good thing about this flyback transformer is this doesn't leak that much and it can give longer arcs at better efficiency. So let's talk about why my circuit is more efficient than the fly ZVA circuit that you see on online. So most of the ZVA circuit that you see on online uses one choke for both of the MOSFET drains, which will push some more current through the flyback secondary, but heat up the MOSFET to junction temperature and kill them. So what I did here is I used a single inductor for the whole circuit, and I used the inductor in the gate side of the MOSFET. As you can see here, the wire comes up here and goes to the gate of the MOSFETs. And the advantage in this circuit is the 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 advantage on this circuit is this single choke feeds both of the MOSFET to turn on and off without making them hot. So, and I use a center tap primary which will push the current evenly through the flyback transformer without saturating the core. So let's start see some arcs right here. Hey, let me get the setup and monitor the MOSFET temperature. So let's get started in 3, 2, 1. Wait, the connections are a bit loose. Yeah, hello. So let's get the arc started in 3, 2, 1. As you can see here, my arcs are bright orange and they are a little white, which means that the arc has high current. The arcs are flickering like that because the fan was on. I have turned it off. So let's run the arcs for 1 minute and see the MOSFET temperature. As you can see, I'm still running the arc. Let's wait for a few seconds. Oh, the clips are getting crazy. Oh my god. Yeah, wait. Yeah. As you can see, as you can see here, the arcs are white and a little bit mixed with a little bit of yellow color. That means the arc is like 8,000 degrees Celsius. Let's extend this arc and see the MOSFET temperature. Wait. Okay, now the arc has been running for a couple of seconds. I have turned off the power supply. So now let's check the MOSFET temperature. That thing is barely warm. Yeah, that thing is barely, the MOSFET is barely warm. Yeah, that's cold. What about this MOSFET? Yeah, this MOSFET is also just a little warm. So, as you can see from here, the flyback and ZV circuit are pretty efficient because I have run those arcs for that long, and the MOSFETs have not got hot enough to explode or need reach junction temperature. Now I'll tell you guys like how to get this kind of efficiency in your flyback and ZV setup. So the best MOSFET to use if you're going 18 volt 0 volt to 18 volt max supply, use the IRF Z44N MOSFET because it has a low gate charge, it has low resistance, and which is perfect for low voltage flyback ZVA setup. But if you're planning to go like 20 volt, 30 volt, 20 volt or 30 volt, the best MOSFET to use is IRF 260N MOSFET. Those are the best for those voltages because they might have a lot of resistance, but they can handle peak current and more temperature than this IRF Z44N MOSFET. But they will draw a lot of amps than these things. And another way to get these IRFs and MOSFETs to run efficiently is to use 100 0 to 100 ohm resistors for the gate because this is IRF for an MOSFET is a fast MOSFET, which means it will oscillate very faster than the other kind of MOSFETs. So the best ohm resistor to use for these kinds of MOSFET is like 0 to 100 ohms. But if you want very efficient switching, use like 82 ohms like I did. I used a 330 ohm resistor and two 220 ohm resistor with in parallel, which means the resistance will drop to 82 ohms. And 82 ohms is perfect for my MOSFETs. And the other ways to protect your ZVA circuit is to use fast diodes like mine. I use the UF 400 diodes like I used two of these diodes in right here. And make sure to use Xeno diodes to clamp the MOSFETs, but to clamp the voltages on the MOSFET gate and source, and this will protect most of the circuit. And the other thing is to use a pull down resistor. I use a 10k pull down resistor on these two MOSFETs because the reason for this 10k pull down resistor is that when the MOSFET turns off, say there is some little energy in the MOSFET's gate and source, which needs to be lowered down to zero because while switching at 60 kilohertz, even the slightest disruption can cause the MOSFETs to short and damage your circuit. So it's better to use a pull-on resistor like I did. And if you want some good thick arcs, make sure to use a 606 primary for your flyback and ZVA setup. And you may think like going to 303 or may even 202 primaries, but for this specific driver, if you go to a higher primary inductance, the flyback will output more voltage with more current. But if you go to a lower primary inductance like 303, the the output current and voltage will be lower. So, and that applies to this specific circuit. And if you're using giving 14 volt to these kinds of ZVA circuit, make sure to use a good inductor like mine, because if you use the normal ferrite inductors or chokes, they will saturate quickly and damage the MOSFETs. So it's better to use a big choke like mine with thick coils. I have harvested this induction from an old induction stove oven, I guess. Yeah, and that's it. That's how you make a good ZVS and flyback transfer. And if you want some good energy transfer, make sure to experiment with this primary caps right here. First, start with the best way to start is start with 0.66 UF. If the MOSFETs are hot, move to a lower primary to a lower primary capacitance. And if you're using a higher power MOSFET like the IRP 260, and do not use 82 ohms like I did. I used 82 ohms for this IRF 449 MOSFET because I have a low gate charge and low resistance on the gate and source. But IRF 6 for IRF 260 MOSFET has higher gate resistance and higher gate charge. So the best for IRF 640 MOSFETs, I mean 260 MOSFET, is to use like 100 ohm, like above 150 ohms. That's a sweet spot for the IRF 260 MOSFETs. And make sure to use the BSC types of flybacks because they leak low, they don't leak that much as the FBT kinds of flybacks, and they give a higher output voltage with a higher current. And my circuit don't use heat sinks because I'm running this at 14 volt. But if you're moving to a higher volt like 40 or even 50, make sure to use some heat sinks for the MOSFETs because even though if it's even though it's efficient, it's not perfectly efficient. You cannot make a ZVS that switches at absolute zero. It might be some voltage like 0.1 milliwatt or something. But if it's efficient like mine. Okay, anyways, that's it. That's how we make this good ZVS and flyback circuit. That's it. And make sure to use a ZVS circuit like mine. I will give you the video in the description. Make sure to check that video. Thank you guys. Bye. And for the end of the video, let's run those arcs for extra 50s for exactly 2 minutes and see the result. Right now the ZBS is running. As you can see, it's arcing through the freaking floor. Let's start the arcs once more for exactly 2 minutes. I'll have to hold this way for 2 whole minutes. Oh, it's getting hot. It's almost 2 minutes. The arcs are crazy. And it's heating the metal tips. 30 seconds before the 2 minutes mark. Let's make the arc shorter. Holy shit, the floor has exploded. What the hell? As you can see, the hotness of the arc triggered the cement on the floor to rapidly expand and explode like this. Oh my god. Look at that. The floor is freaking exploded. Let's try to find the chip. Yeah, but I think it scattered everywhere. So let's check the MOSFET temperature once again. Yeah, now, nah, the MOSFETs are still warm. yes, my circuit is pretty efficient. But the primary wires are a bit warm, but it's okay. The MOSFETs are still just a little warm, not near junction temperature. If they were at near junction temperature, I could not have been holding this for this long. Let's check the flyback core. Yeah, that's wrong. Yeah, the flyback is entering saturation mode. Let's check the choke. The choke is a bit warm, but it's okay. Resistors are fine. Tank caps are running cool. Yeah, and my ZVS is perfect. This in the efficiency scale. So and that's it, guys. Take care. Bye. I'll give you the circuit diagram in the description.